Hey everyone, this is your Algebra 2 Lesson 6-2 notes on polynomials and linear factors. Our I can statements for today's lesson are I can find all rational zeros of a polynomial function, and our other goal is to recognize the connection among zeros of a polynomial function, x-intercepts, factors of polynomials, and solutions of polynomial equations. So for example 1, they want us to write the expression the quantity x plus 1 squared times the quantity x minus 2 as a polynomial in standard form. And this is just like in lesson 6-1. We are going to first multiply x plus 1 times x plus 1, and then we will multiply that product times x minus 2. So if we create a box here and put x1, x1, that will be taking care of this part. And we will get x squared, 1x, 1x, and 1. So this part is equal to x squared plus 2x, combining our like terms along our diagonal, plus 1, and then we're going to multiply that by x minus 2. So then I'm going to create another box, and I'm going to have x squared, 2x, 1x, and negative 2. So when I multiply along my first row here, I am going to get x cubed, 2x squared, and x. And now when I multiply this row out, I get negative 2x squared, negative 4x, and negative 2. Now combining like terms, and we see that our diagonals are like terms, we get x to the third power. And our 2x squared and our negative 2x squared are actually going to cancel. And then when we combine x with negative 4x, we'll get negative 3x, and finally minus 2. So we get a cubic polynomial that has 3 terms. So it is a cubic trinomial. I know it didn't ask us for what kind of polynomial we had, but we're still going to answer it. Why not? Okay, next, the U try. If you can pause your video and try this on your own, and then hit play and see if you get it right. So we have x minus 3 and x minus 5. And when I multiply all my parts together, I get x squared minus 8x plus 15. So I just did a quick FOIL using the box method. And now I'm going to multiply that product times x minus 2. I would like to do another box. It's just simple. Good way to organize our work. Make sure we don't leave anything out. Going along the top row, we will get x cubed, negative 8x squared, and 15x. Now going along our bottom row here, we get negative 2x squared, positive 16x, we have a negative times a negative, and then negative 30 here, okay? Now, combining like terms along our diagonals, we get x to the third power, the only thing to the third power. We get negative 10x to the second power. Negative 8 and negative 2 gives us negative 10. We have 31x, 16 and 15 give us positive 31. And finally, the negative 30 at the end, which is what I was trying to say when I got tongue-tied. This is cubic. Highest degree is 3, and it is a polynomial. It has 4 or more terms. Okay. Now we are going to factor. I know several students have expressed, at least we're not factoring anymore. Well, we're going to factor. So now I'm going to look for a GCF first. But my GCF is not just going to be a number. It is going to be a coefficient along with a variable. So my greatest common factor when I look at each term is actually 2x, not just 2, because every term has at least 1x. So when I divide everything through by 2x, now bringing 2x to the outside, because that's what I'm dividing everything by, I'm actually left with 2 x's on the first term, check. On the second term, I'm left with a 5 and 1x. And on the last term, I'm only left with the number 6 because both x's will cancel. Then I can factor what's on the inside here, and since my leading coefficient right here is an x, I can go ahead and place an x here and an x here because I know that x times x is x squared. Now all I have to do is think of two numbers that'll multiply to give me 6, that'll add to give me 5. You guessed it, 2 and 3. I fill it in with 2, I fill it in with 3, and that is the factored form of our original expression. It says you can check by multiplication, and you sure can. I'm not going to on these video notes because they're already going to be pretty long. Next, you try. I'm going to divide everything by a greatest common factor. It appears that everything is divisible by 3, and every term has at least one x. So now 3x moves to the outside, and what I'm left with here is 6 divided by 3 is 2, and I'm left with 2 x's. Here, 15 divided by 3, or sorry, negative 15 divided by 3 is negative 5, and I'm left with 1x. And right here, negative 36 divided by 3 is negative 12, and my x's cancel. And it looks like my leading coefficient right here is not 1, so I cannot simply put x and x. But I do feel confident that it's going to be 2x and x, because 2x times x is 2x squared. And I'm going to go over here, do a quick box, and just check out what it is. So 2x squared will go here, negative 12 will go here. I'm going to multiply the diagonal, and I get negative 24 is my magic number. So I need two numbers that'll multiply to give me negative 24. That'll also add to give me the middle term, and let's go way back over here, and that was negative 5. And so after we brainstorm for a bit, we're going to figure out that it's negative 8 and 3. Sure enough, negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5. I fill in my blanks along with an x. Now I'm going to do greatest common factor this way first, which is 2x. Greatest common factor this way, which is 3. Greatest common factor this way is x. And greatest common factor this way is negative 4. Both of these had a negative going this way, so that's why I chose negative 4. So, along with my 2x goes a 3, and along with my x goes a 4. You could do a quick FOIL to check your work. And sure enough, I promise it works. So the answer is 3 times the quantity 2x plus 3 times the quantity x minus 4. All right, on our next unit test, you're going to be given questions about relative maximums and relative minimums. You can simply graph any quadratic function, and wherever you see a hump here and a hump there can be a relative min or a relative max of a cubic function, okay? Keep in mind that it's only a relative min or a relative max because there is no real max. This guy right here means it is continuous and goes up to infinity, positive infinity, forever and ever. And this right here means it goes to negative infinity, forever and ever. But right here I have what's called a relative maximum, and right here I have what's called a relative minimum. And these are concepts that you're going to hear when you get into calculus. So be familiar with this interval notation, that it's increasing or decreasing from this point to this point, and then it starts doing this. And so just knowing the behavior of the graph as you move from one point to the next. What's the graph doing? Okay. As you can see here, I'm going down. Here I'm going up. Here I'm going down. So that's the graph's behavior. We also have x-intercepts. And so being familiar with where it crosses the x-axis, we have learned that those are our zeros. We can also call those our roots, our solutions, and obviously our x-intercepts, just outright calling them that. Okay? All right, next, find the zeros. So can I look at a factored form of a polynomial and be able to immediately state the zeros? Well, yes, you can. This guy, and this guy can all be set equal to 0. Which means that we have a 0 at 2, we have a 0 at -1, and we have a 0 at -3. And we're not going to sketch the graph for the purpose of these notes today. You are good to go knowing that you have x-intercepts at 2, -1, and -3. So pause the video, Try this next one out and then hit play to see if you got it right. Set each one equal to 0, because that's where the zeros are at 0. And it looks like we have an x-intercept at 7. We have an x-intercept at 5, and we have an x-intercept at 3. Isn't that easy? I always liked these problems. I thought they were very easy when I was in school. Okay, moving over here. Can we go backwards now? Can I give you the zeros and then you write the polynomial equation? So if you know there's a 0 at x equals -2, at x equals 3, and at x equals 3, that means you solved something that said x plus or minus a number equals 0. So I'm going to think backwards, and I'm going to move it back. And when I move it back, it looks like I started off with x plus 2 equals 0, and I started off with x minus 3 equals 0, and x minus 3 equals 0 again. So it looks like we've got x plus 2 times x minus 3 times x minus 3. Okay? And to write this in standard form, you would create your box, multiply it out, 2x, -3x, -6, and you would get x squared minus x minus 6. And now that was only this part. Now I'm going to multiply it by this part. And I create my box. I've got to squeeze this in here. I'm so sorry. And I got -x, I've got -6, and I've got x, and I've got -3. X to the third power, -x squared, -6x, -3x squared, 3x, and 18. Going along the diagonals, gives us this final answer. Now, I understand that I'm writing fast. I need you all to understand that you're very capable of pausing, rewinding, or just simply watching to make sure you absorb the content, okay? How you go about these video notes is totally up to you, but you do have the capability to do any of those things at any point. Pause, rewind, you name it. Your job is to understand the material, so do not let the technology get in your way. You control the technology, okay? Finally, we are going to have, I'm going to jump straight to these and show you how easy it is. I just think opposite. Opposite of -4 is 4. Opposite of -2 is 2. And if I have a factor at 0, I actually just need, I think it'd be silly to put that, don't you? So I'm actually just going to put an x at the end, or it'd be just as simple to put an x at the very beginning, which is where you'd see it. I'm going to distribute right quick. I'm not going to draw a box. That might be silly. Okay, now I'll draw a box to get my final answer, which you could probably just foil right there and not draw a box at all. It's up to you. But if you like getting into this habit of drawing the box, it is a nice, simple method. Sorry, positive 8x. Okay, so final answer, x cubed plus 6x squared plus 8x. Notice there is no constant term, and that is okay. Last but not least, equivalent statements. You've heard these already. I've told you guys when I talk about a solution, I'm talking about an x-intercept. When I'm talking about an x-intercept, I'm talking about a 0. The only thing not listed here is a root, so that goes with this. And I can also say that I'm solving, but one thing that we haven't really mentioned is that x plus 4, the fact that it's a factor of this means that it is a solution. What solution? X plus 4 equals 0 is the solution, so therefore the x-intercept is at -4. So if I can tell you that something is a factor of a polynomial, that factor set equal to 0 is also a solution, and x-intercept is 0 or root. Okay? I hope these notes have helped, and if you have any questions, email or just ask. All right, thanks guys.